Let's practice solving a quadratic trigonometric equation together. While there can be an infinite number of solutions for these equations, we're going to focus on just the solutions that are between 0 and 360 degrees, including 0 degrees, but excluding 360 degrees. And if we have to do any rounding, let's go to the tenths place so we're consistent together. And real quick, before we get started, if you'd like a free download of this blank PDF or the annotated answer key PDF, you can find those in that description box. Alright, let's get into it. So to get started, I'm just going to go ahead and copy this down. So we have 7 multiplied by this tangent squared of theta, plus we have 13 multiplied by this tangent of theta. Then we're going to go ahead and subtract 10, and then that's going to be equal to negative 6 multiplied by tangent of theta minus 4. To handle these type of quadratic trig equations, it's helpful to use a little strategy called u-substitution. Basically, with u-substitution, we're going to go ahead and just let u represent a more complicated part of the equation, so we can go ahead and actually solve it and then switch it back later. For this particular equation, let's just go ahead and say let u equal this tangent of theta. Okay, so we're going to, every time we see this tangent of theta, we're going to substitute it with u. Going ahead and making that substitution, this is going to be 7 times, well, tangent squared of theta is just going to be u squared because it's tangent of theta times tangent of theta. And this is going to be plus 13 times u, because that's tangent of theta again. Then we're going to go ahead and subtract 10. There's no u's there, and then that's going to be equal to negative 6 multiplied by tangent of theta, but we're going to substitute in u for there, and then minus 4. Alrighty, so we let u represent this tangent of theta, so each time we saw a tangent of theta, we changed it to a u. Later on, once we get to the end of the problem, we'll go ahead and switch that substitution back so that we can actually solve it. Hopefully at this point, this just looks like a standard quadratic equation, and we want to put it into standard form and set it equal to 0. To do that, we can go ahead and add 6u to both sides of the equation. And we can also add 4 to both sides of the equation. When we go ahead and use those properties of equality, we're going to have this 7u squared. Then we're going to have plus 19u. And then that negative 10 plus 4 is going to be negative 6. And that's going to equal 0. Now let's go ahead and factor this. So let's go ahead and set up 2 binomials and set this equal to 0. I know that we're going to begin with a 7 and a 1 in front of each of these. So this is going to be 7u and 1u just because 7 is prime. So we know their coefficients have to be 7 and 1. And if you put a plus 3, then the outers multiplied are going to get 21u. And then we put a minus 2 over here, then the inners is going to be minus 2u. So we'll get that positive 19u. Now to figure out what makes this equation true, let's go ahead and set this binomial equal to 0 and then set this binomial equal to 0 as well. So I'm just going to go ahead and do that on the side. So if we have 7u minus 2 and that's equal to 0, we can go ahead and add 2 to both sides of that equation. So we get that 7u is going to be equal to 2. And then if we divide both sides by 7 here, we find that u is going to be equal to 2/7. And for our other binomial, we have u plus 3, and that's equal to 0. If we go ahead and subtract 3 from both sides of that equation, we find that u is equal to negative 3. Now remember, since we said u was representing tangent of theta, we know these u's in these locations can be represented by tangent of theta, so let's swap those back out. Okay, so going back over here, we can go ahead and say that we know that u is going to be equal to 2/7, and u is also equal to negative 3. And so making that substitution, get a little bit more space here, we can go ahead and say that tangent of theta, which is what we originally wanted to know, that's going to be equal to 2/7, but then tangent of theta can also be equal to negative 3. Now for the equation on the left here, where tangent of theta is equal to 2/7, if we're going to look for theta here, we can just say that theta would be equal to arctangent, or the inverse tangent of this 2/7, right? That'll give us that angle. And for this equation on the right, to find out theta here, if we know tangent of theta is equal to negative 3, we can say that theta would be equal to arctangent of negative 3. All right, so solving these will give us our angle measures. On the left side, if we plug this one into a calculator, we should find out to the nearest tenths place that this angle measure theta will be about 15.9 degrees. And on the right side, for this arctangent of negative 3, that's going to be approximately negative 71.6 degrees. Now, while we found out these two angle measures here, let's remember what the parameters were for what theta could be. Remember that for this particular problem, we're looking for angle measures that are between 0 degrees and 360 degrees. So while we like this 15.9 degrees because it fits between this range, we don't really like this angle over here to the right where we have negative 71.6 degrees, right? So keep in mind that what we can do here to take care of that is we can go ahead and find another coterminal angle. So if we add 360 degrees to this, it's going to bring us to the same location, just another revolution around that circle. If we go ahead and do that, then the same location is going to be about 288.4 degrees, okay? And this is going to fit between 0 and 360, so we like this one better. Now at this point, you really may think you're done, but I'm sorry to say that you're still not quite there. There are a couple more solutions we're looking for between 0 and 360. So while 15.9 degrees is one of our solutions, and 288.4 degrees is another one of our solutions, remember that our tangent function repeats every 180 degrees, or pi, and so that we're going to have infinite solutions every pi. So for the one on the left here, for 15.9 degrees, we should write our general solution as theta being this 15.9 degrees, but it's really going to be plus or minus 180 degrees. So I'm just going to go ahead and say that we can also add 180 degrees here, just because subtracting 180 will take us out of this 0 to 360 range. So adding on another 180 here, then we can also say that theta is going to also be equal to 195.9 degrees. This right here would be our third solution between 0 and 360 degrees. And over here to the right, if every 180 repeats, if we add 180 to this 288, that's going to be out of that range of 0 to 360. So if we go ahead and take this 288.4 degrees and subtract 180 degrees, that's the same thing that's going to happen here, then theta is going to be also equal to 108.4 degrees. Between 0 and 360 degrees, this would be our fourth solution. So putting this all together in a solution set, we can go ahead and say here that theta would be equal to this 15.9 degrees, as well as this 195.9 degrees, as well as 288.4 degrees, and 108.4 degrees. Now keep in mind, there are infinite solutions for this equation, but these are the four angle measures between 0 and 360 degrees that make this equation true. Now hopefully if it helps to see this visually, I can hopefully show you a little bit on a graph or unit circle what this would look like. For these two angle measures, we have 15.9 degrees and 195.9 degrees. Our 15.9 degrees would be in quadrant 1, just say right about here. And we knew that ratio for this one was going to be what? I think we knew it was going to be a ratio of 2 to 7. Remember, that's the same thing as y over x. And so if we looked at that y to x ratio here, we knew this was going to be 2 and this was going to be 7. So if we go ahead and find out that angle measure of theta, if you do tangent, that's opposite over adjacent, or y over x, so we do get that 15 over 9. Now what about this 195.9 degrees? That's going to be over here, over in quadrant 3. And so why does this also work? Well, keep in mind here that we have theta, and that's actually that reference angle of same as 15.9 degrees. But this is going to be a -2 and a -7. But if you take tangent of this, a negative over negative is still positive. So remember, tangent is positive in quadrants 1 and 3. So this is why both of these work. And hopefully you can also see why we're adding 180 degrees, because they are making a semicircle, or they're 180 degrees or pi radians away from each other. And then looking at over at these two angle measures, 288.4 degrees would be somewhere over here in quadrant 4, right? And so that over here would create this triangle that would look something like this, okay? And then so what's that going to look like? Well, we had a ratio over here of tangent theta was -3. So again, that's going to be equal to -3 over 1. And that's going to be our y over x, right? Or opposite over adjacent. So -3 over 1. Opposite would be of theta would be -3. And adjacent would be 1. So hopefully that makes sense why that would be over there. And then if you were to move over in this direction where 108 degrees, that reference angle would be right over here. And then if you drew a triangle down, you could also see that this would be a +3 and a -1 this time. So if you do opposite over adjacent, or y over x, you're also going to get -3. So that's how I would go about solving this particular quadratic trig equation. If you found this video helpful, please consider giving it a like and sharing with a friend or classmate that might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.